Gopi, working as an assistant professor in EC department in Srivastava Institute of Engineering and Technology, Nangaluru. Today I want to discuss the serial port and its programming in 8051 microcontroller. My 8051 microcontroller has 4 parallel ports. One serial port. So what is port? First of all, we have to understand what is port. So port is a platform where the goods or passengers get in and get down, just like airport and seaport. Here in computer language, a port is a platform to wait the data and data bits. So in serial port, it is an integrated UART. It is an integrated UART. UART means universal asynchronous receiver and transmitter. Universal asynchronous and receiver transmitter. So in data transmission, we need to know what is whether the data is transmitting or receiving, or how much rate, what is the rate of the data transmission. These all must be controlled. So there is a need to control these parameters. So it has 2 resistors for controlling data transmission or receiving. That is called control resistors. Those are called control resistors. In this, there are 2 control resistors are there. 2 resistors. One ELE-COM, serial port control resistor. Serial port control resistor, and SBUF, serial port buffer resistor. Serial port buffer resistor. So these 2 resistors are used to control the serial port, and one more bit, that is the MSB bit of PCOM resistor. MSB bit of PCOM resistor, that is called SMOD. PCOM resistor, power control resistor. PCOM resistor means power control resistor. So it is an 8-bit resistor. PCOM. It is an 8-bit resistor. It is an 8-bit resistor. So the MSB bit is SMOD. This is called SMOD. 2 bits are not used. GF1, GF1, power down, ID. This is the format of PCOM resistor. In this resistor, this SMOD, if SMOD is equal to 1, that is the normal baud rate. Normal baud rate set by the ELE-COM. Normal baud rate set by the ELE-COM. So what is baud rate? Baud rate means bits per second. That is the frequency of data transmission. The frequency of data transmission, baud rate. That is the number of bits. Baud rate is equal number of bits transmission, either transmission or receiving per second. That is the baud rate. So this bit, if this bit is 1, that is the normal baud rate set by the ELE-COM resistor. This ELE-COM resistor will be explained later. Suppose if it is 0, the baud rate is double. The baud rate is double. If it is 0, the baud rate is double. These two bits are for general purpose flags. General purpose. So we focus on this bit only in serial communication. This PD is the power down. Power down. So generally it can be operated in power down at 2 volts. This is ideal, like sleep mode in desktops and laptops. So we next week coming to the SPU, serial port buffer resistor. Actually, there are 2 resistors. These are 2 8-bit resistors. 2 8-bit different resistors. Two 8-bit resistors with the same address. This is called a double buffered resistor. This is called a double buffered resistor. This is called double buffered resistor. One is used while reading and another is used while writing. So in this one, the data is serial. The data will be buffered in this 8-bit resistor. While transmission, this 8-bit data is converted into serial, and while receiving, serial to parallel conversion will be done. Next we discuss about the ELE-COM. Serial control resistor. Serial port control resistor. It is also an 8-bit resistor. It is also an 8-bit resistor. It is also an 8-bit resistor. The 8 bits are specified. The format of the is given SM0, SM1, SM2, REN, TB8, RB8, TB8, RB8, T1 and R. This is the format of the ELE-COM resistor. This can be programmed by the programmer, whether what is the baud rate you need, whether the transmission or the receiving of the data from the from or to the external devices. That all you can be programmed by using this 8-bit ELE-COM resistor. First 2 bits, that is the MSB bits. This serial mode, this defined serial mode. Serial mode bits. This is used for, this modes will be discussed later. This is used for multi-processors and this is the receiver enabled. This bit can be set by the programmer to receive or transmit data. And this TB8 and RB8, these are rarely used. And this is the indication of transmission of the 9th bit. So you have to know about this ninth bit. This ninth bit is the parity bit. Along with the data bits, parity bit will be transmitted for error checking. Whether the data is correctly transmitted or received can be checked by the parity bit. This is the transmission here, and this is for the receiver. Whether these bits will be set if the data is transmitted or received. After transmission or received, these bits will be set. And now coming to the serial port modes. These two bits defines the mode of the data transmission. If these as two bits are there, we can get the four combinations 0 0 0 1 1 0 1. These four combinations. First mode, this is the mode 0, mode 1, mode 2 and mode 3. So these four modes. We discuss the what is the baud rate and the data transmission can be explained in each mode. In mode 0, shift register 8-bit shift register, and in mode 1 8-bit UART. 8-bit UART. Here 9-bit UART. Here also 9-bit UART. 9-bit UART. In 8-bit UART, here baud rate will be discussed in mode 0. The baud rate is 1/12 of the crystal oscillator or crystal frequency of the microcontroller. 1/12 of the crystal frequency. So in 8-bit UART, so the baud rate is variable. The baud rate is variable. So variable and can be generated by the timers by programming the timer resistors. Can be generated by programming the timer resistors. This how to program the timer resistors are discussed in the previous video. And in this one, the baud rate is 1/32 or 1/64th of crystal frequency. So next, in mode 3, here also baud rate is variable. Can be programmed by this baud rate can be generated by programming the timer resistors. So the timer resistors, how to program the timer resistors are discussed in the last video, and you can see that. And now let we discuss one example how to program the ELE-COM resistor for the required baud rate. Suppose in mode 0 we need to operate in mode 0. We need to operate the serial port in mode 0, and whether transmission or receiving. Just I want to receive the data from in mode 0. So in mode 0, we have to program the ELE-COM. For mode 0, MSB bits of the ELE-COM is 0 0. Now ELE-COM is equal 0 0 for mode 0 operation, SM2 for that is for multiprocessing, so we can keep generally 0. Next, receiver enable, so we need to keep 1 for this one. Next, TB8 and RB8, this is for a 9th bit operation. After receiving the 9th bit, this will be 0 0. and here transmitter and receiver initiated by 00. Initially these two bits are set by the hardware, and in transmission and receiving is during 1 to 0 transition. So we need to these two bits can be cleared by the programmer, and these two bits set by the hardware. Okay, this ELE-COM bits will be 0, 0, 1 according to our requirement. It is that means 1, 0 in 10 in hexadecimal. Okay, right? 10 in hexadecimal. So we can program the ELE-COM like this. So we can move this 10H. We can move this 10H to the ELE-COM register by using the move command. Then the serial port of the 8051 is operated in mode 0 in the receiver section. In the receiving operation. So in this one, we need to, what is the baud rate? What is the baud rate? Baud rate can be calculated by this equation, 1/12 of the crystal frequency. Suppose let the crystal frequency for simple calculation, let the crystal frequency is 12 megahertz. Yes, crystal frequency is 12 megahertz. Then baud rate can be calculated. Baud rate in mode 1, mode 0 is equal to 1/12. So we can write 12 megahertz by 12. Cancel. So that is 1 megabits per second. That is the baud rate, 1 megabits per second. Hertz means 1 megahertz means bits per second. So in this one, the data will be transmitted with 1 megabits per second in mode 0. Sorry, received in mode 0. So like that, you can calculate or you can program with the required baud rates by programming the timer registers. Okay, thank you.